Hello, everyone. Can you hear me?
Yes, I can hear you.
Great, great.
Hello, everyone. This is Anton here.
Hi, welcome to join us, the first webinar. This is Zishan from OS, and Anton is my colleague. We both hosted this series of webinar. So as you know, this is the first time, and we want to make it weekly event so we can share our experiences with Dragonfly and answer your questions. We have about 14 people registered, so let's wait a couple of minutes. So I'm going to share my screen now. Okay. All right. So welcome again to join the webinar. As I said in the email, we want to make it a weekly event, and every time the webinar itself will be about half an hour. Then we have 10 minutes for questions and answers, for discussion. Today I will demonstrate the very basics about Dragonfly, because I know some of you have used Dragonfly for some time, and some of you may be new. So I'm going to share the very basic ideas and the concepts, the operations in Dragonfly. I know we have already made a lot of video tutorials, which you can find on YouTube. It's very useful. Our product manager, Mike Marsh, he recorded lots of very good tutorials. And I also know it's sometimes it's difficult for like non-native English speakers, because Mike speaks very fast. So for me, I'm not trying to reproduce everything he has done. So I'm trying to explain maybe more like the concept with more data set, different cases. And also I try to speak slowly. I'm not a native speaker, English speaker either. So English is my second language, and I guess most of you is the same, because I am in charge of our marketing in Asia. So most of you are from Asia, I believe. So I encourage you to ask questions. We don't want the language to be a barrier for anyone. I don't want it to stop us from communicating or from getting help from each other. So be free, feel free to ask questions, and also we keep it in mind that we have to speak clearly and slowly so everybody could understand.
I can also add, please also type, if you prefer, you can type your questions in the chat box. And if we don't get to answer your question, or you have a specific demo request for a future webinar, or even just for us to make a short demo video for YouTube, we can gladly do that. So my name is Anton du Plessis. I'm quite new to Dragonfly, so I'm looking forward to this webinar series to share also to support Zishang and to share what I have learned in the last 6 months, and to also improve my own skills. So I look forward to the series, and I hope you also enjoy it.
Thank you very much, Anton. It's very nice to have you. For everybody's information, Anton joined the OIS 6 months ago. He's a very senior scientist and engineer, especially in CT imaging and additive manufacturing. Anton is based in South Africa, but he's part of our team. So if you visited YouTube recently, you probably have found a few video tutorials made by Anton. They are very nice. I learned also. So I encourage you to go to YouTube and see again. So you just search like OIS Dragonfly, you will find our channel. We're going to publish or post more videos as soon or as many as possible. It depends on your request. So let us know your questions and let us know your needs. So we'll be happy to answer either in the webinar today or in the next weekly webinars, or we can answer you by making video tutorials, as Anton said. All right, so I'm going to start now for today. You can see my screen. It's a micro CT data of one nut. It's very clear, and I would this is the credit of the data which I downloaded from. It's a public domain data, so you can download also the raw image data set. As I said, I want to go through some basic ideas. So maybe for the advanced users, if it won't be very helpful, but I still hope it could be a good one for the beginners. So after we load the dataset, it could be a TIFF stack or a raw the file or any other image files. But after we load them into Dragonfly, it's a 3D image dataset, and we can view them by different layout. I'm not going to do this just quickly. The main task for many people is to analyze or to visualize the structures or the regions of interest. You probably want to render your data or sample more clearly with colors, or you probably want to measure some like the volume or surface area or some other measurements you care about. So the very important step is to do segmentation, as you know. So we have, because it's very important, and we have so many tools for segmentation. So it has its own tab here. So the main tab is for manipulation of the images. You can see many tools here. And the segment tab is obviously for segmentation. So we normally create ROI, which is region of interest from here. So we do ROI creation. We could create a multi-ROI. I will explain what is a multi-ROI later, but now we just create a new ROI, which is a region of interest. So when we create a new ROI, it's new, it's empty, it's nothing here. So you see the labeled voxel is 0, and the volume fraction, of course, is 0 too. So the very basic or very often used method for segmentation is thresholding. Thresholding means you define a range. So you don't see thresholding here, but it's the same idea. You define a range. Range is for the intensity, because we know every pixel has an intensity in the CT image. So it's a grayscale value. So by define a range, you see I could label, or I could see which pixels are in my range. So the color you see now, when I change the bar here, you see the color indicate what pixels have the intensity in this range. This is my selected range. And I can also show the histogram. So now you see the range maybe better. This is a range I selected. You can also input the numbers for a gray value if you want, or you can save the numbers for the gray value. You can reuse them later. So by visual inspection, I mean, you can see what regions has been selected in this range. When this selection of the range is good, like for your purpose, so we can add all pixels to new. I'm sorry, add all pixels. This button is to add all pixels to my selected ROI, which is this one, the one I just created. So if I do this, I added all pixels to my ROI. So now I have an ROI with labeled pixels. If I refresh here, we see the labeled voxels number. It's 7 million something. And we see the volume fraction. The volume fraction, the percentage is the volume of this ROI relative to the whole volume of the data set. So it's the cube of the volume of the cube. So this means the volume of my labeled pixel, which is green here, versus the total volume of the data set. So I just did a very basic segmentation, as you see. Oftentimes we need to separate them because you see now everything in the wallet, like the shell, the kernel, even the bed, the holder, all labeled because they have the same range in of the intensity. If we do a separation by connectivity, we right-click the ROI, we could find the connectivity tool, which is here the connected components. And if we do this, this will separate. You see, this will separate the ROI to many different small classes, and each class is separated from the other classes. So which means it's not connected to the other region or the other classes. And if we do, this is the count of the pixels for each class. You will see the biggest class has almost all the pixels in this ROI. So now I'm looking at the multi-ROI created from the ROI by connectivity. You see the largest class. If I hide the color, you will see it has almost 99% of all, which means all the pixels in this class are connected to each other. It's very obvious, like the bed is connected to the walnut by here, and the walnut, the shell is connected to the kernel somewhere. Maybe if we don't see it in the current slice, it could be another slice. So it's connected somewhere. The one not connected, for example, like this one, this single pixels, we always call them islands. So these are islands isolated from the major region because they are not connected to each other. For those small pixels, mainly from the noise. So we can see we could remove or delete all the classes which are already isolated by connectivity very quickly. For example, I can delete, I can select all here. Just 1 second. Okay, I can select all. I deselected the largest one. Then I can delete, remove all other classes. Then I will have only one class, which is the biggest connected component. Or I can right-click the largest class, the first class, and I can extract as a ROI. So I can go back from the multi-ROI to an ROI. To the multi-ROI, now I got only one ROI, which is the largest class from the multi-ROI, which is the largest component, all connected. But this normally this is not exactly what I want. What I want to remove the bed, the holder from the walnut image, and I probably want to separate the kernel from the shell. So to do that, we can see by the range, by the thresholding, we're not able, and by the connectivity analysis, we're not able to separate them. So I'm going to show you very quickly, maybe by 10 minutes, how to do this by Watershed. The Watershed is an algorithm. We can find the boundary of two different regions. We'll see that quickly. So I'm going to start over again. Okay, start over again. I'm creating new, not ROI, I'm creating multi-ROI now. So you will see that it depends on how many regions I want to separate. So I want one for the bed, one for the shell, one for the kernel, maybe one for this. I'm not expert of walnut. I don't know what the name for this, but I want to put make the central part as one separate region of interest. So I would say maybe 5 classes in total, including the background. Background is the air. So I make 5 classes multi-ROI. Now every class is empty again. It's new one. So what I want to do is to place the we call seeds. So I'm going to place the seeds in each region by the manual painter. So this is the ROI painter tools. You can paint an ROI, or you can also paint a class in a multi-ROI. So you have to select the multi-ROI, you select the class you want to paint. And this is the painter I'm going to paint now. So it's very straightforward. I selected this brush. This is a round brush. This is square brush. And this is single slice or multi slice. If you choose multi slice, when you paint, it's not only paint on the current slice. You see the current slice is this one. If I scroll to the other slices, the adjacent slices, you see it's also painted because it's a multi-slice painter, a brush. So I'm going to use the single slice brush for now. It's easy to understand. So I can brush anywhere I want. For the first one, I was name it as bed. So I can paint bed. You don't like you can the what I'm painting now are the seeds. The watershed will make the seeds grow. So for example, I put this class as the shell. You don't have to name them, but with the name it's easy to remember and you don't get confused later. So like I put the shell here. Oh, this is my shell. This is also my shell, and this is oh, and this is I don't know what is this one. This I call it the kernel 2. And maybe I want to put it here. This is my air. Okay, I put it here. So you see, I put a few seeds here. For each class, I have one seed. So the watershed will make them grow. And the watershed algorithm can tell you where to stop for each seed. For example, this blue seed will grow and stop by the boundary here. And the green, the air region will also grow and stop here. So the watershed will help you find the boundaries between two classes or two regions. There is some tricks here, or you see for example, the air. I'm not sure from this slice if the air are all connected to each other. I mean, the air inside the walnut, it may be separated from the air outside the walnut. Well, I'm not sure about that. If I want to know, I have to go through all slices and find out if they are connected or not connected. that is not easy to do so. And I don't care because I could put 2 seeds here. I could put one inside and one outside. And Watershed will use both as one seed. So it will grow from two locations. It will grow at the same time. So which means if I'm not sure about the connectivity, I place more seeds. And for shell, I'm pretty sure this one's connected to this one. So in fact, it's not necessary to put 2, but it doesn't hurt if you put more. If you are sure about the, it doesn't hurt to have more seeds, but it's not necessary because anyway, it will grow to all the region with the similar intensity. And for this kernel, for example, I'm not sure this one and this one, if they are connected somewhere. So I just simply put 2. And for this kernel, I probably move it to, maybe I take this one also. Okay, so you can place the seeds on any slices. It doesn't have to be in the same direction. I mean, you can place it in other views, the other direction of the slice. For example, you can put this kernel here or here, and this one here. Now we have placed the seeds for Watershed. And the second step for Watershed is to create a landscape image. The landscape image will give you more information about the edge, about the boundaries. Because the original one, you see the boundary, yes, but it's not very clear. It's not enhanced. So it doesn't have a very contrast, a very high contrast for the edge. So to do that, we use image filtering. In the workflow, we have image filtering. Normally, we go to Sobel filter. Sobel filter is it's edge detection filter. So you can see the preview. This is to compute the preview. Now, from this slice, by Sobel filter, I can get this slice. So you see the image has much better contrast for the boundaries. And we're going to use this filtered image as the landscape for Watershed because it provides better information about the boundaries. I'm going to do the Sobel in 3D because I have a 3D dataset. This one is okay. We can apply Gaussian before Sobel. If the preview is fine, we just do apply. It will create a new image dataset by applying the filter to all slices. So now it's computing, and now it's done. We close this tool. See, I have created a new dataset here. If we take a look, this is the Sobel filtered one. So I'm going to use this one as my landscape for Watershed. To use the Watershed tool, as I said, we have prepared this. We have to prepare the seeds first, which we have done. After that, we right-click the Multi-ROI and we choose Watershed Transform. Now it says choose a landscape. Oh, that's why we have the Sobel filtered one here. Then it says choose an ROI as mask. You don't have to use a mask if you want segment all the pixels in the image. But sometimes you don't want to segment the background, for example. If you don't place a seed in the background, then you can use a mask. The mask has like to mask out the background. The mask it doesn't include the background. Then all the seeds will grow and stop by the edge of the background. So it won't grow into the background. So it will stop there because of the mask. But now I do have a seed for the background, which is the air. So I don't need a mask because I want all regions to be segmented. I want all my seeds to grow. up to the whole volume. So I see no mask. Oops. All right. Yeah, I'm using a free account of Zoom, so that we have a 40 minutes limit, but which is okay for us. As I said, I will demo normally for 30 minutes. Then we have a few minutes for discussion. So in any case, the meeting is stopped by Zoom. We are not going to come back. So if that happens, we'll see you next week. All right. So now we have done the watershed. You can see the same multi-ROI. The seeds have grown to the full volume. You see the air. We can hide the one class. We don't want to see the air. You see the bed. So it's a full segmentation in 3D. It's not. Let me show you in 3D. You see the bed has been. You can even render it in 3D. Well, I think the 3D rendering has some issue. It doesn't look correctly. This is an issue. Don't take it as the real segmentation I have done.
Try to put the image channel off, Zishan.
Image channel off.
Oh, okay. It's
Maybe I can.
It's a rendering issue, I think.
Maybe I can refresh and get it back. No. Maybe I have a clip box. Oh. Well, it didn't happen last time to me. When this happens, oh, let me do this trick. When this happens, it's an issue. Sometimes we can fix it by switching the layout. Here we go. By switching the layout, it refresh the view. So now it has been refreshed and updated, and now we have a proper 3D view. We can, in 3D, we can, for example, this is the bed. If we hide the shell, we can see inside, but now we see the volume itself. So I can put the volume opacity to be lower. Here we have a global volume opacity. I can put this lower, so we don't see the volume. So we don't see the image. We see only the segmentation, which is the multi-ROI. I can put color to make it look better. So you see, this is the volume opacity. And if I want to see only the segmentation result, which is the multi-ROI, I could either close the data, the 3D visibility for the data, or I can keep it open but move the opacity to be 0. Or we can have a fusion of both. So this is the shell, and this is the inside, another structure inside. And yeah. So I guess that's it for today. So it's a workflow of multi-ROI creation by Watershed by placing the seeds manually. Sometimes you don't place the seeds manually. For example, if you have thousands of particles or even tens of thousands of particles in your image, you are not able to place the seeds manually. In that case, we have other tool or other method to create the seeds for Watershed by, for example, distance map, or by histogram segmentation tool. We could talk about those tools in the future webinars. But today, because I have only like a few big regions to separate or to segment, so it's very easy for me to place the seeds manually.
That was very nice. Thanks, Zishan. I actually didn't do it like that before, so that's useful for me also. Are there any questions from the floor?
Yeah, now it's time for discussion. If you have any questions, it doesn't necessarily have to be related to what we have demonstrated. It could be any questions for Dragonfly. So feel free to ask. Or any feedback or any expectation or any idea about this this webinar. So I will be happy to hear. All right. Well, if it's okay if you have no questions, which totally fine. Right.
There's one question in the chat box. Let's see.
Oh, I didn't see the text.
Let's see.
Yeah, I'm reading now.
How is somebody asking how they can download the recorded video?
That's right. We have recorded. We'll keep this. I'm not sure if I want posted in YouTube or not, but I will share with you by email with a Google Drive link, so you can download it at least for now. So Anton, you recorded, right?
No, I didn't record.
Oh,
but someone
is recording.
Somebody is recording. So
I thought it was you, so I didn't record because I know someone is recording,
so
but it's not.
Whoever is recording in the audience, please send us the video.
Yeah. I'm sorry. Who is recording? Please send me by email the recorded file.
Okay, there's another question from somebody that I recognize the name, Arun Tori. How can you differentiate two different regions in the data with similar intensity?
Mm-hmm. Well, it's difficult if the intensity is very similar. It's especially difficult for thresholding, the traditional method. If you want to do it by thresholding, if they are very similar, I mean, like they look almost the same, it might not be feasible or durable to separate them, because we need to know how to differentiate them. If we don't see it visually, we probably not able to do it by hand, unless we have other modality, unless we have other images which show them in different features. Like for example, if you have another scan of the same sample with different energy of the X-ray, maybe you see them differently. Or if you have another EM image to tell you the difference between two regions. But if you have only one CT images, you could differentiate two regions by eyes. You can see the difference. Then we can use deep learning. Even we are not able to use the traditional method like thresholding, we are able to use deep learning to separate them. But as long as you can visualize, you can see the difference by eyes. Because if you don't, you are not able to provide the ground truth for the deep learning method. If you have no ground truth, you are not able to train a model, a neural network, to do that.
Yeah, and this is Arun's second question was, does machine learning tools do the machine learning tools help in this case? So yes, for sure. And I think that's one of the strong points of Dragonfly is the machine learning tools. So we will cover that in future lessons. I think the idea here is to stick with the easier things first. Mm-hmm. And I think this, when you have two similar intensity regions which are just touching, which is the case here actually, walnut and the base are basically the same grayscale, and they're only touching. So the watershed